Hello and welcome back to our next video in our practice problems for chapter 4. So we're going to pick up right where we left off, which is problem 11, in which we have a 2x2 contingency table above here. And it's broken down by drugs with electrocardial device, drug therapy only, hospitalized / died, and non-hospitalized / survived. So problem 11 asks us to find the absolute risk reduction for patients hospitalized in drug therapy and drugs with electrocardial devices. So the way we figure this out is, remember, the best way to do this is to always make sure our table is set up correctly, and that's where we have a control group on the bottom. Most of the time we're going to have our disease on top of what we're looking at, and when we set up our 2x2 table then we just label our boxes A, B, C, and D. So for number 11 we're finding the absolute risk value. Absolute risk value, you might see it sometimes abbreviated ARR, and this is the equation. It's the absolute value. That's what these symbols on the side are, the absolute risk. So we're taking any value and turning it into a positive value. And we're taking A over A plus B, subtracting it from C over C plus D. So if we have our values in our boxes here of A, B, C, and D, and we write that out, you'll see it's 159 over 383. Remember, 383 is A plus B. And then we're going to subtract it from 250, which is C, over C plus D, which is 430. And remember, we're taking the absolute value of this problem. So when we write this out, breaking it down further, is 3.4151 minus 0.5813. Well, as you can see, you're taking a smaller number here from a larger number, so you're going to end up with a negative if you do it this way, but since we're doing the absolute value, it's going to be positive. So this equals negative 1.662, and then we take the absolute value, which then equals 0.1662, which is our absolute risk reduction value. The next part for numbers 12 and 13, for number 12 and 13, they actually have you flipping this chart or this 2x2 table in a couple different ways. So to help avoid any kind of confusion, I've put the 2x2 chart for you here for each problem. So this is number 12 and this one is for number 13. I already kind of wrote off to the side. But if you look, you're just taking these values and you're kind of just rotating the chart in certain directions based upon where they're putting the control group. Remember, the control group's going to be on bottom, and then they're putting those individuals who only receive drug therapy as part of where like your C value would go. So remember, we're always putting our boxes as A, B, C, and D. So if we look at number 12 here, number 12, so this would be A, B, C, D for number 12, and we're trying to find the relative risk. So relative risk is found with this equation up here, which is the A over A plus B divided by C over C plus D. When we write this all out, it looks like 159 over the total of A plus B, which is then 409, divided by C, which is 224, divided by the total of C plus D, which is 404. Put this in decimal form. So once again, I like to take everything step by step. If you do that, there's less error potentially involved. If you try to throw it all in your calculator, absolutely you can. Make sure you're putting in your parentheses around the whole equation, because if you don't do that, then you're telling the calculator to perform different tasks in different areas. If you break it down step by step and kind of do orders of operation on your own and not leave it up to the calculator to do, you'll probably be better off. When you put it in decimal form, it's 0.3887 divided by 0.5544. Divide that out, you get 0.701, which is the relative risk. Relative risk is just a way of saying, what is the risk associated with receiving drugs with electrocardial device against the control group with individuals who only receive drug therapy, and we could see that the relative risk is just 0.71, which is it really is not much. If we have anything of a relative risk over the value of 1.0, if you have a relative risk of a value over 1.0, then we say that that is a potentially harmful risk, whatever you're looking at that is harmful. Anything less than 1, so 0, -1, we start saying that's more of a protective factor involved. But when it's really close to 0 or 0.701, next to 1, there's a slight risk, but not a crazy amount. Problem 13 wants us to find the odds ratio. Once again, they're kind of flipping that 2x2 table around, and so I've labeled it over here for you. Oh, that's A, B, C, D, jumping ahead. And you can try to mimic that yourself if you like. Just follow where they're putting the compared to as your control group, which is going to be on the bottom. You can go and try to flip the chart yourself. When you do that, you're going to have and we're trying to calculate an odds ratio. Odds ratio is found by taking A times D divided by B times C. And if you go to our 2x2 table and then express this out in the formula that we need to do, so it's A, so 224, times D, which is 250, divided by B, which is 180, times C, which is 159. Oh, hello. 159. Sorry about that. Technology. When you break this out, now once again, you can put this all in the calculator and divide out. If you want to be fancy, I like to break it out step by step. Multiply this out, you get 56,000 divided by 28,620. Divide that out and you get an odds ratio of 1.9566. So it's the odds of patients who are hospitalized or died in the drug therapy versus those who are taking drugs with electrocardio device. Moving on to number 14 here. So number 14 has us assume a child with brown eyes or blue eyes, and they're equally likely. So they're just doing two eye colors. Of course, we know there's more, but for the purpose of this problem, just 2. So we know that the probability is equal to 0.5, kind of like a coin flip, right? 50% either blue or brown, and they're independent of each other. So now we want to try to find the probability of having 5 children with brown eyes. Since brown eyes is an option, we can actually do this, and we have 5 children we're trying to look at. So the way we do this is we take our probability and we put it to the power that we're looking at. So 0.5 to the 5th power is equal to 0.03125. So if we live in a world with only brown eyes or blue eyes, and we wanted to pick 5 children randomly, and they can only have brown or blue eyes, what is the probability of picking 5 children with just brown eyes? And we would say that's 3.125% chance, or I guess we could round that to 3.13% chance. So there's a chance, but it's pretty small. Next part here. Why is there a G there? Maybe that's what I added in there. That's interesting. Anyway, moving on. Number 15. How many ways can a set of 12 medication prescriptions be organized to a 7-day calendar? Once again, you can do this by hand. I highly recommend using the calculator. All calculators can do it. You're looking for your NC of R value on your calculator. You'll see the book sometimes right as NC of X. They're meaning the same thing. This is the rate or the number you're looking at, X, the quantity you're looking at. So this one, we have a set of 12 medications organized into a 7-day calendar. So the all 12 medications have to be used, and then 7 days is our variable here, right? Because you could put all medications in one day, or you could put them all in Wednesday, or all in Tuesday, or you can divide it out and to put 3 pills across 4 days, or you can divide however you want. Put 11 in one day and then 1 in another. There's totally different combinations, and that's what we're doing here. We're using our C as our choose or combination function to figure out how many different ways that can be possible. So we put this in the calculator. Is 12, C, 7. Now, every calculator is going to be a little different depending on which one you want. Always email me if you have a question about your specific calculator. Some of them are very nice to put them in. Other times you have to put like a value of 12, find then your choose function, and then hit 7, and then that will be how it reads is 12 choose 7. And you put that in there, that you should get 792. So there's 792 ways that you can organize those 12 medications into a 7-day calendar. Number 16, we have kind of a very similar setup where we're using our choose function and C of X, in which we have 3 nurses from 11, and we want to, how many different ways can you select that to be done? So this would be 11 choose 3, which is equal to 165. All right, I'm going to go through number 17 relatively quickly, because once again, I'm going to assume that you read the problem and at least attempted or tried it, so I'm going to kind of just write this out real quickly. Once again, so we're at a wedding, and we're trying to figure out what is the relative risk of developing a disease of eating chicken versus steak. So we're going to have a 2x2 table set up here, in which, remember, when we put disease on top, so you're either going to be diseased or not diseased, and then we're looking at chicken versus steak and the guest who eat it. So after reading the problem and going through it, you're going to find out that people who ate chicken and got sick were 64, people who ate steak and got sick was 28, people who ate chicken and did not get sick is 48, and people who ate steak that did not get sick is 100. So a total of 126 here and 112 here. Remember, our relative risk formula is equal to A over A plus B divided by C over C plus D. When we put these values in here, we're going to say it's 64 over 112 divided by 26 over 126, which is equal to 0.5714 divided by 2063, which gives us a relative risk is equal to 2.7697, which tells us that we would say that guests who had chicken were 2.76 times more likely to become ill than those who ate steak. You can kind of see that if you ate chicken, you were 2.76 times more likely to become sick than those who ate steak. And this is another way just to show how relative risk is done. Once again, it's all about setting up the 2x2 table. Disease goes on top, exposures on the side. And once you have that all set up, looking through the problem, you should be able to solve for the relative risk. All right, that is all the time I have for this video. When I come back, I will do the last part of the chapter. I'll see you all in the next video.